Okay, so Brinkelhoff is important because all of these elements, except for phosphorus and sulfur, we'll talk about those in a sec, are two molecules. So it's Br2, it's O2, it's Cl2, et cetera, et cetera, et cetera. They never occur by themselves in nature. So when you see a chemical reaction, and I say zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. What do you write for hydrogen gas? H2. H2 gas. All right. The two other weird's not the right word, different ones are phosphorus and sulfur. Does anybody remember what sulfur and phosphorus form? It's never, sorry?
P4 and S8.
Yes, it is. It's sulfur is always S8 and phosphorus is P4. Okay. All right, you're going to have to get good at, especially when we get into the next unit, so this is the beginning of it, translating a word, like a sentence basically, into a chemical equation. So, the word equation, sodium and chlorine react to form sodium chloride. The key is, this is why we have to remember Brinkelhoff. When I say, I'm just going to say chlorine. Chlorine is part of Brinkelhoff, so that's Cl2, right? So Na and Cl2 form sodium chloride. Salt. That's what I'm trying to say. Okay. By the way, this is like not a simple reaction. It is a violent exothermic reaction. We'll talk about what exothermic. Do you guys know what exothermic means?
Emits energy.
Emits energy. So it's not a nice reaction because chlorine gas is not something you really want to mess around with. All right, but it forms a nice molecule that you can eat. Table salt. What's wrong with the equation?
It's imbalanced.
It is. It's what?
Imbalanced.
Imbalanced? Unbalanced?
Isn't imbalanced the word?
It's not balanced?
Wait, hang on, I'm looking this up. I'm pretty sure imbalance is a word.
Okay. I just haven't heard anybody say that.
Yeah, imbalance. Lack of balance.
It is not balanced. In other words, we have two chlorines here. There's only one there. All right? We're going to get into balancing things today. So it's not balanced. We're going to talk about that later. All right, conservation laws. This leads us to conservation laws. If a system is closed, do you know what a closed system means? Nothing. Kind of walked right into that one. Nothing can leave if it's all contained, okay? So if you have a closed system, the number of atoms, the mass of the system, and the energy of the system all remain the same. Okay? So what this leads to in chemical equations, is the total mass of the matter and the total number of atoms present before a chemical change is always the same as the total mass and the number of atoms present after, i.e., it has to be balanced. Now, this isn't to say that they look exactly the same. You've all seen chemical reactions. I mean, if you look at this one, this is not the same as this, but the total number of atoms needs to be the same. Okay, how do you balance that anyway, by the way?
2Na plus Cl2 goes to 2NaCl.
Yeah, if you have a 2 there and a 2 there, then you get balanced. That would be a balanced system. All right. So the individual particles don't change, just how they are arranged. But that's the chemical reaction. So conservation of mass leads to writing balanced chemical reactions, which is what we're going to start today. You do balancing in grade 10, right? It's very important. Okay. No, you've been waiting for this the whole time. Okay. Oh. What's wrong?
I'm buying these pens. Look, they're colorful rainbows. Oh yeah, I have a colorful rainbow pen. They're racing.
Is that what you're looking for? Before, after, and arranged.
That's supposed to be a rate. It looks like a noise. It does.
I'm annoyed with you right now.
Hold up. How much money do I have? Let's check.
All right, are we ready? Are we ready? People at the back?
Oh wait.
Actually, two specific people in the back.
There's tips for balancing.
Okay, here we go. Balanced chemical equation. So you all hopefully have done this before. The total number of each kind of atom or ion, we'll do that later on, has to equal the total number of the same kind of atom or ion in the product. So left-hand side has to equal the right-hand side, essentially. All right? You do this by adding coefficients in front of the chemicals, all right, or the molecules. So this says, for this balanced chemical equation, it says 3 molecules of nitrogen dioxide react with 1 molecule of water to form 2 molecules of nitric acid. I'm just trying to remember the name of it, plus nitrogen oxide. All right. Okay, here we go. So first thing you got to be able to do is figure out how many of each atom there are. So the coefficients apply to everything. We're going to do the last one here. This one. So we have nitrogen, we got hydrogen, we got carbon, and we got oxygen. How many nitrogens are there?
10.
Peoples?
Looks like.
So we have this 2 applies to the nitrogen, but you have 5 of these molecules. So it's 5 times 2. You have 10 nitrogen atoms. How many hydrogens do we have? So the 2, there's 4 in NH4, but we have 2 of those molecules because of this 2. I'm going to zoom in here. So that's 8, and then we have 5 molecules. 5 times 8 is 40. Carbons? How many carbons?
5.
You have 5 because it has a subscript of 1. There's no coefficient except for the 5. The 5 applies to the whole thing. So it's 5 times 1, which is just 5 carbons. And then oxygen, 15, because you have 3 in the carbonate, and you have 5 molecules here. So 5 times 3 is 15. Oops. Okay. Are you ready to start balancing? Are you excited to start balancing?
No.
Balancing's fun.
See?
That's kind of boring.
You agree with me.
Here we go. All right. Use pencil, please. Look, I can't make you use pencil, but I strongly encourage you to use pencils because if you make a mistake, you can erase it. All right. You can only change coefficients. You cannot change. So, for instance, on this one, or we'll look at this one. If I need more oxygens, I can't be like, oh, well, I'm just going to go OH and do that. Right? You cannot change the subscripts. You can only change the coefficients, the numbers that are in front. Okay? So don't do that. All right. Balance the metals first. These are guidelines. These are suggestions. All right. I'm going to burn through this, but then it's easier when we just practice it and you start to see it in play. Polyatomics. So do you have like these things? You know that page in your data booklet that has all the sulfates, phosphates, nitrates, carbonates, all those things. If they stay together in the molecule or in the reaction, We'll see it in a sec. Balance them as one thing. Okay, and I'll show you that in a sec here. Balance the nonmetals, then balance carbon, hydrogens, and oxygens. We might be using fractions, people. We'll learn how to deal with fractions, okay? Sometimes the fraction is your friend, and then we learn how to get rid of it later, okay? If you have pure, this doesn't say, if you have pure elements, balance them last. I always balance pure elements last, okay? All right. Are we ready? Are we excited?
Yes.
Here we go. See, balance the elements last. There it is right there. Okay. If you want, you can write them down on the side.
That's been happening like the past 30 minutes. You've just had your back turned every time.
Really?
Yeah.
Oh. Okay. All right. So we got zinc pure. It's all by itself. Don't even touch it. Leave it to the end. Okay. We got HCl, zinc chloride, and hydrogen. Pure. Leave it by itself. Okay. So what do we want to balance first? The HCl. You got to pick an atom to balance. What atom do you want to balance? What's out of balance?
Hydrogen and chloride.
Hydrogen and chlorine, right? There's 2 chlorines on this side. There's 1 there. There's 2 hydrogens here. There's 1 there. So what should I do? Put a 2 right here. Then I'm going to give me 2 chlorines. Then check it. I've got 2 hydrogens. I've got 2 hydrogens. I've got 2 chlorines. I got 2 chlorines. I got 1 zinc. I got 1 zinc. We're good. All right. Next one. CO2 plus hydrogen goes to methane. That's methane. Plus water. All right. What do you want to do? Okay, what do you want to balance first? CO2. What do you mean when you say the CO2? You got to balance an atom. You got to pick an atom to balance. Okay, so what's atom balance? 1 carbon, 1 carbon, 2 hydrogens, 4, 6 hydrogens, 2 oxygens, 1 oxygen. Do you want to balance the hydrogens first? Sorry? Yes. Balance the oxygen. Leave the hydrogen to the end because it's a pure element here, right? We can manipulate that without affecting anything else. So I'm going to balance the oxygens. I have 2 on this side. I have 1 on this side. So what do? I'm going to put a 2 there. Now the oxygens are balanced. Does that make sense? Okay, but now we've messed up the other stuff. So you check again. Carbon's good. Oxygen is good. So you look at the hydrogens. I have, how many hydrogens do I have on this side? I got 8, right? 2 times 2 is 4, plus those 4. I have 8. So what number do I need to put here to balance it? 4. And it's balanced. All right. Okay, polyatomics. Balance them as 1. Again, do I want to start with the magnesium? No, because it's pure, so you leave it. Copper again, pure, leave it. So we look at the polyatomic, the nitrate, NO3. Okay? How many NO3s are on this side? 2 NO3s, right? Because of that 2 there. So what do I put in front of the copper nitrate? I'm going to put a 2. So now I have 2 NO3s. I have 2 coppers. So I can balance that because I have a pure copper on that side. I could just throw a 2 in front. Is everybody good so far? All right. Okay, we got iron 3 chloride plus beryllium phosphate goes to beryllium chloride and iron phosphate, iron 2 phosphate. So, what do you want to balance first? Balance the polyatomic. All right, you only have one polyatomic. You have the PO4. You have two of them on this side. How many are on the other side? One. So how do I make the one that become a 2? Multiply by 2. So I throw a 2 there. So I got 2 phosphates on each side. So I'm happy. I have what am I looking? I have 2 irons here. How many irons do you have on this side? You have 1. How do I make that 1 a 2? You put a 2 in front of it. Boom. So the irons are balanced. The phosphates are balanced. What's left? Chlorines and berylliums. Okay. How many chlorines are on this side? 6. How many are on this side? 2. How many berylliums are on this side? 3. How many on this side? 1. So what am I going to do? If you put a 3 here, that should fix all our problems, right? If I put a 3 there, then check it. Okay, just go through. 2 iron. 2 iron. 6 chlorines. 6 chlorines. 3 berylliums. 3 berylliums. 2 phosphates. 2 phosphates. Okay? All right. Oh. An atom appears in more than 2 places due to loss. Okay, so we got methane plus oxygen plus the carbon dioxide and water. What do you want to balance first? What do you want to leave to the end? Let's start with that. I'd leave the like this to the end, right? We're not gonna mess with that. So how many carbons? 1. 1 carbon. We're good. So let's balance the hydrogens then. We have 4 hydrogens on that side. How many do you have on that side? 2. So what do I do? Put a 2 in front of the H2O. Okay, so I got 4 and 4. How many oxygens are on the right-hand side? How many oxygens are on this side? No, there's 4 now, right? With the 2? 2 plus 2 is 4. How do I turn that into 4? Put 2 in front. All right. C3H8, that's propane. Plus oxygen goes to CO2 and water. These are called combustion reactions. We're going to learn those next week. They always produce carbon dioxide and water at combustion reaction. All right, what do you want to balance? Are you going to balance oxygens first? Leave it till the end because you've got this thing. So balance the carbons. You got 3 carbons. I need 3 on that side. So I'll throw a 3 right there. So that balances the carbons. Now we got to balance the oxygens. I have 8 of them here. I've only got 2 there. What do I do? How do I make 2 become 8? Put a 4 there. Then you look at your oxygens now. 3 times 2 is 6. Plus these 4 give me 10. How do I make this O2 become 10 oxygens? Let's throw a 5. Okay. Are you ready for the fractions? Here we go. Same type. It's a combustion reaction. Acetylene. No, it's not. Yes, it is. At the- All right. C2H6 plus O2 goes to carbon dioxide and water. So balance the carbons first. Okay. I got 2 carbons. I need 2 on that side. So I go, okay, 2. Then look at the oxygens. I've got 6. I've only got 2. So what am I putting on that side? Putting a 3. Okay. Are we with me? All right. How many oxygens are on this side?
7.
7. 2 times 4 is 2 times 2 is 4, plus the 3 is 7. All right. I can't make O2 become 7. So you have to do a bit of fakery for just a little second. If what you want to do is that number, that 7 that you want, if you write it as 7 over 2, what's 7 over 2?
3.5.
3.5, right? If you went 3.5 or 7 over 2, if you like fractions, times 2. Like if you did that, if this is a math class, I know it's not, but if you did it, 7 over 2 times 2, the 2's cancel and you get 7, right? Okay? But you can't have half of a molecule. That doesn't work. So how do you get rid of fractions?
Double up.
You multiply everything by whatever the denominator is. So everything here gets multiplied by 2. Okay? So times 2 times 2 times 2 times 2. So then you end up with 2C2H6. Those 2's will cancel and you get 7O2, 4CO2, 6H2O. Then what should you do before you move on? Check it, just to make sure. So 2 times 2 is 4 carbons, 4 carbons. 2 times 6 is 12 hydrogens. 6 times 2 is 12. 7 times 2 is 14 oxygens. 4 times 2 is 8. Plus the 6 here is 14 oxygens. All right. Are we okay? All right. Just a couple more, then I'll give you practice. Acid-base neutralization. We'll learn all these names later. So H2S, NaOH forms sodium sulfide and water. Okay. What should we balance?
Sodium.
Balance the sodium. So 2, I need 2 sodiums on that side. So I throw a 2 in front of it. Is the sulfur balanced? Yep. Okay. I've got 2 plus the 2 hydrogens here. That's 4 hydrogens. Yes? So I need to get 4 hydrogens here. So I just put what in front of the water? A 2. And then you have to check your oxygen. Usually, like it says here, the oxygen sorts itself out. Okay? 2 oxygens. 2 oxygens. Okay. You want to try the next one on your own? Balance the last one, please.
Well done.
Yeah.
Would I be allowed to like borrow a lab coat from the school?
You could borrow it to wear at the school on Halloween Day. Is that what you mean? You ready for it? Oh, sorry. Are we ready? 2, 3, blank, 6. So balance, what you would do is balance the strontiums first. The SR, the cation. There's 3 there. You put a 3 there. Then balance the phosphates. The phosphates, PO4. So I put a 2 there. Then I look at the hydrogens. Oxygens always last. 2 times 3 is 6. There's 2 there, plus this 3 is 6, so there's 12. So I have to put a 6 there. Then you balance the oxygens. But note, please, that if you're balancing the oxygens, you don't include the PO4 because we treated that as one sort of identity, right? The PO4 we already dealt with as a PO4. So you don't count those. You just count these oxygens. That's 2 of them, times the 3 is 6, and there's 6 there. Okay? Yes? All right, peoples. The next page is you practicing your balancing skills. Please.